Something weird is happening on the surface of Betelgeuse, Orion's red supergiant on its deathbed. The star made headlines in December 2019 when it unexpectedly began to dim, hitting a historic low in brightness by February 2020, a phenomenon later dubbed the Great Dimming of Betelgeuse. Although it regained its usual brightness later that year, it made astronomers curious, prompting them to direct some of the most powerful telescopes toward it for a closer look. What they discovered was astonishing: the surface of the star is boiling and creating a cosmic illusion. Betelgeuse is a big deal. It's one of the most intriguing stars in the night sky. It was born in a stellar nebula and spent 90% of its life in the main sequence phase, burning hydrogen into helium in its core. However, since the mass of Betelgeuse is about 15 times that of the Sun, it followed a different evolutionary path. Instead of turning into a red giant, like typical Sun-like stars, it evolved into a red supergiant. Betelgeuse has captured the attention of astronomers because it is rare to observe a star in its final stage of evolution with the naked eye. This makes it a valuable laboratory for understanding the processes that precede one of the most violent stellar events, a supernova. The last significant supernova observed in the Milky Way was Kepler's supernova in 1604. Since then, no other supernova has been observed in our galaxy within the naked eye limit. So, naturally, anything that happens to Betelgeuse is a big deal. Even as Betelgeuse's brightness diminished, astronomers speculated that this behavior might be a precursor to an impending supernova explosion. To investigate further, they used the Atacama Large Millimeter Submillimeter Array, or ALMA, to closely monitor the supergiant. Observations from ALMA revealed that the dying star appears to be spinning rapidly, with speeds exceeding those predicted by current laws of physics. This was confusing. Why does Betelgeuse seem to be spinning faster than any other star of its age? Is this seemingly rapid rotation a sign of the impending supernova? Just as the explosive event of a supernova like Betelgeuse triggers a cascade of cosmic reactions, learning a new language sparks a dynamic burst of activity in your brain. Let me introduce you to the sponsor of this video, Babbel, one of the top language learning apps in the world. Learning a new language with Babbel can be a real game changer, especially in those funny, lost-in-translation moments. Like that time I tried to impress my Spanish-speaking friends by saying I love the beach, but instead, I accidentally said I love the shovel. They couldn't stop laughing. Babbel helps you avoid these mix-ups. It's proven to help you start speaking a new language in just 3 weeks with lessons from real teachers, making learning personal and practical for everyday life. You can even try live classes, choose from various plans including a lifetime subscription, and enjoy a 20-day money-back guarantee. ¿Quieres empezar? As viewers of this channel, you get 60% OFF on your subscription by clicking the link in the description. So let us know what language you would like to learn in the comments. The first hint that something unusual was occurring with Betelgeuse came from the star's surface radial velocity map provided by ALMA. A surface radial velocity map is a visual representation that shows the speed at which different parts of an object, like a star or planet, move towards or away from an observer. It uses colors to indicate the speed and direction of the motion across the object's surface. ALMA's observations revealed that one half of the star's visible hemisphere was blue-shifted, indicating it was moving towards us, while the other half was red-shifted, suggesting it was moving away. These data were crucial in accurately measuring the star's rotational velocity. When these results were compared with the Hubble Space Telescope observations, it was confirmed that Betelgeuse was apparently rotating rapidly. There are theories suggesting that this unusual high rotation rate might be explained by Betelgeuse having once been part of a binary system, where it absorbed a lower-mass companion star, a process sometimes referred to as celestial cannibalism. While this is not uncommon among red supergiants, there is no conclusive evidence of this in Betelgeuse's case. However, if Betelgeuse evolved as a single star, its fast rotation surprisingly deviates from predictions. To understand why the fast rotation of Betelgeuse is problematic, we need to comprehend the sheer size of the star. Betelgeuse is 15 times more massive and about 1,000 times larger in diameter than our Sun. If it were in place of the Sun, it would stretch out to engulf the Earth and extend all the way to Jupiter's orbit. Moreover, Betelgeuse is no longer a main sequence star like the Sun, it has evolved into a red supergiant. As stars like Betelgeuse age and cool, they expand. According to the principle of conservation of angular momentum, this expansion should cause their rotation to slow down. Additionally, they lose mass through stellar winds, which also contributes to a decrease in their rotational speed. Current theory suggests that red giants should rotate at speeds around 1 km per second, and red supergiants, like Betelgeuse, at even slower speeds, typically less than 0.1 km per second. Yet, Betelgeuse defies these expectations by rotating at about 5 km per second, which is 50 times faster than what is typical for stars in its category. To solve the mystery of Betelgeuse's unexpectedly high rotation speed, astronomers had to confirm whether the rotation they observed was real or just an error in measurement. They considered the possibility that other activities on the star's surface could be misleadingly interpreted as rotational movement. To delve deeper into this issue, astronomers utilized the ALMA telescope, which comprises 66 individual antennas of various sizes and is one of the most advanced radio telescopes in operation today. Using ALMA's capability to observe submillimeter wavelengths of light, astronomers examined the hot gas in Betelgeuse's outer atmosphere. The researchers aimed to find out if Betelgeuse's rapid rotation was actually being mistaken for something else happening on its surface. They suggested that what might be going on is a process called convective flow, which is how stars like Betelgeuse move heat around. In convection, hot material rises to the star's surface because it's lighter, while cooler, heavier material sinks. This creates big swirling patterns, known as convective cells, that look like giant boiling bubbles. These patterns can extend from the star's outer layer deep towards its core. The team theorized that these boiling bubbles might be creating an illusion of rotation, with one group of bubbles rising on one side of the surface and another group sinking on the opposite side, making it look like the star is spinning by causing some parts to come towards us while others move away. This movement could explain the blue-shifted and red-shifted regions observed in ALMA's maps. To test their idea, the researchers created a computer model of a non-spinning red supergiant star with a boiling surface, just like Betelgeuse. They compared the model's behavior with actual observations from the ALMA telescope. Surprisingly, the simulated star and the real observations matched up perfectly. This confirmed their theory that it's not the fast spinning we're seeing on Betelgeuse but instead, its surface bubbling up like a pot of boiling water. This bubbling effect is so strong that even the most advanced telescopes can't tell the difference between this and the star actually spinning. The study provides more evidence of Betelgeuse's unpredictable behavior, which isn't a new phenomenon for astronomers. In the past, Betelgeuse has been at the center of surprising events. For instance, the Great Dimming episode almost 4 years ago was finally explained by the theory that the star had expelled a large amount of hot gas. As this gas cooled outside the star, it formed dust that temporarily blocked some of the supergiant's light, making it appear dimmer from Earth. In 2023, Betelgeuse showed another strange behavior. Its brightness increased by about 50%. Initially, astronomers thought this might be a precursor to a supernova explosion. However, further analysis revealed that this was actually a lingering effect of the 2020 Great Dimming. The massive release of dust and gas during that event disrupted Betelgeuse's normal cycles of brightness, which usually include cycles lasting 400 days, 185 days, 230 days, and even as long as 2,100 days. The disturbance from the Great Dimming specifically altered the 400-day cycle, shortening it to just 200 days and causing an unexpected increase in brightness. Predicting when Betelgeuse will go supernova is a complex task because it's difficult to determine its exact stage in the stellar life cycle. Scientists need to know whether Betelgeuse is in the helium-burning phase or the carbon-burning phase. The timing of the supernova largely depends on this. At 550 light-years, we are at a prime vantage point to witness this cosmic spectacle. When a supernova does occur, the first clue would likely be a surge of neutrinos, tiny particles that are emitted in vast quantities during a supernova explosion. The Supernova Early Warning System, or SNEWS, uses a network of neutrino detectors to look for these early signs. Following the neutrino burst, a supernova would release a tremendous amount of energy, becoming so bright that it could be visible during the day for about 2 to 3 months before gradually fading. Although a Betelgeuse supernova would be a spectacular sight and pose no danger from its distance, it would leave a noticeable change in our night sky. Betelgeuse serves as one of the shoulders in the constellation of Orion, and its loss would mean Orion would appear missing a shoulder, with the remnant of the explosion not visible to the naked eye. Many people ask whether we can study Betelgeuse using the James Webb Space Telescope and predict its supernova accurately. Well, the answer is no. Webb, although extremely powerful, isn't suitable for observing it. It is designed to observe distant and faint celestial objects, but Betelgeuse is about 1,500 times brighter for the sensitive detectors of JWST. So, we can't use it to predict the star's accurate evolutionary stage.